So, so we have developed a cloud SCADA system that brings advances in control strategies. Control strategies fundamentally are focused around yaw settings, yaw misalignments, and we have an open wind systems approach for on-demand wake steering, and this delivers, importantly, increased capacity, power, performance, and profit. We use a software as a service system for wind farms with integrated analytics across the enterprise with a permissions managed views, which means anybody is able to look in and see what's going on in the system, from investors to executives to operators. We delivered an independent 5G data network with aggregation via autonomous sensors and drones. That's something that we do with Qualcomm, and then we do multidimensional parallel systems to achieve continuity of SCADA. In other words, we're not going to interfere with the current system's operation in order to be able to function. Any wind farm, old, new, or planned. But before we go any further in digging into each of these, I want to just dive into a presentation that I made in February for Leadvent around the future of the wind farm and get to the importance of all of the data that we're referring to here. So if you think about 2030 and the future of the wind farm, you see a lot of innovation with turbines getting a lot bigger, and we'll talk about that in a second in terms of why that's happening, but it's all about revenue. It's all about power. It's about creating more, not necessarily the concept of profitability. And I would take issue with the presenter yesterday who found it more important to focus on what's going on the wind farm. I think what you do is you focus on what's going on the wind farm in the context of making sure that you can increase capacity and increase power. That's what we deliver on. People are investing a lot of money in capacity from storage. There are other ways to do it. We'll talk a little bit about that more. So what's different? We have a digital revolution, and you've heard a little bit about this. Sorry about that. You heard a little bit about this in terms of collecting data through autonomous drones earlier in the conference. We're going to show you a little bit about how that happens in a way that doesn't interfere with the operations of the wind farm. There's going to be a lot of things going on. We're going to talk a little bit about data, the cloud, and business. And in 2030, data really is going to be a huge awakening. That's going to come from many different places, and it is the voice of the wind farm. You've seen the graph on the left many times during this conference. That's the focus when you're thinking about yaw misalignments and wake steering. We'll talk more about that. We've all got to be better at this by 2030 if we're going to win. Right now, we're seeing an explosion of data sources, and the explosion of data sources is in many cases interfering with the way people need to operate. But I think if you're operating in an effective way around the cloud, you can get past that, and we're going to show you how with 5G. So now we're on our way to the data becoming more valuable, data creating value, creating more power, and so this is what it's going to look like. It's going to be harvested from literally thousands of sensors on a wind farm, and with the 5G implementation in a parallel network, you can do that without interfering with anything you're doing on the wind farm. 2030 cloud is going to be very, very different. It's going to change everything. We're going to be in the middle of that. Collect, integrate, predict, and we're going to show you how we're doing a lot of that right now. Centralized data, accessible data collection, meaning multiple places, and with lots of ability to work between different systems. And then normalized data with analytics and visualizations, critical to what we're doing, and the integration of machine learning. That is a big piece of what's changing the way we can do things on the wind farms now. We're doing a lot of that. We're at the heart of that. And so really it's the cloud that changes everything. It enables real-time site planning. You're going to need real-time site planning when you go to deep water offshore. And you're going to need to be able to select the best way in which to face the turbines from many different options. You're going to need to be able to figure out how to do, which turbines you're going to be thinking about putting in different places. And then repowering and replacement are going to be big, particularly onshore, as you know, with the opportunities that we're seeing now. The business, things are going up and to the right. We know that in all respects, and that's because of the additional power. Larger turbines are driving costs down, but as they drive costs down, they bring a greater capacity, and that greater capacity brings greater volume and allows for lots of different business models that include allowing, in New England, they're doing a lot with enabling towns to have fully free, power, and that's a big thing. But automation is coming, and you saw some charts on this before. We're going to show you a little bit about how you can utilize wake steering to move those wakes away from those downstream turbines that you can't see in this diagram. Opportunity is the biggest bottom line in history, and so we all have to get a head start, get moving, listen better, and so now preserve the data, embrace the cloud, listen to and enhance your business. So now, getting to 2021, we're built for the journey, for the wind farm of the future. We're doing it now, and with strong POCs, developer, owner, and finance customers, and backing of making all of this happen without the wind farms absorbing the cost of doing that. And so again, we show you this diagram, this slide with the things that are happening. To go through these bullet by bullet, open wind systems approach means utilizing all of the data from all of the turbines and all of the sensors that we can put in place on a wind farm to support each other collaboratively. Intelligent operation. Bringing software as a service enables the wind farms to have integrated analytics across the enterprise, permissions managed view for different job titles. The independent 5G network is a data network that allows for aggregation via autonomous sensors and drones, and that can happen without any kind of impact on the existing wind farm. And then pretty critical here is to have multi-dimensional parallel systems that can achieve continuity of the current SCADA. And so it's a parallel SCADA environment that interfaces with the 5G network and interfaces with the cloud without interfering with what's going on with the existing SCADA system, and is managed in a way that works with a wind farm plan for on-demand implementation of new control strategies. So let's talk about that, more specifically now as you look at what the Vayu Cloud SCADA system looks like. Users will interface with a Vayu data login system that will show the user everything that they're entitled to see from within the wind farm. Our data system is supported by one of the great data companies, Palantir, which is a strategic partner. And we'll show you what Palantir is doing in a couple of seconds. But fundamentally, the Palantir is functioning by looking to the Vayu Cloud, which is providing the optimizations and the simulations that are coming from data that is coming from the edge. And so we have Vayu data, which is interfacing with the cloud, which is interfacing with the edge, which is what's happening on the wind farm. And on the edge, we're working with Qualcomm to deliver intelligent systems that can offer new information, SCADA directly from the wind farm SCADA, but from additional drones and other sensors that are working together to provide information that runs in parallel to the SCADA. So we get the parallel SCADA, integrate the data from drones and sensors, and then in the Vayu cloud, we send the data to Vayu cloud, which runs the simulations and develops the appropriate control strategies for any given set of conditions for every turbine on the wind farm, implemented on the turbines pursuant to control strategy permission systems that are coordinated with the wind farm and the OEMs. So backing off and just looking at Vayu data to see what the user sees, Vayu data associates itself with Vayu cloud. In Vayu data, what we're seeing is the data visualizations that are prepared based on the simulations and the third-party data integration, derived analytics, with data processing and machine learning happening against that data, with extensive monitoring and security. There are in every case there are data diodes and similar technologies to avoid things being processed by the users that they're not entitled to process. Vayu Cloud, which interfaces with Vayu Data and also with the edge, is the place where we're doing the really extensive simulations and integrations that are happening between the multiple systems. And so with data and control strategies coming from the cloud to the edge based upon the combination of new assessments based upon data coming in from the edge. We're running these at whatever cadence is most appropriate for any given wind farm, and then those systems end up sitting at the edge, available for the turbines to coordinate with. And so, how that works is, on the system that is associated with the 5G private network. So the Vayu Edge on our Qualcomm systems are hearing from the drones, other sensors on the blades, and interfacing directly with the SCADA system. And so running in parallel, developing the control strategies, and then delivering those approved control strategies to the turbine control interface. Now, the turbine control interface is managed, can be managed by the OEM. That's our preference, because then we can intersect with OEM concerns for warranty protections and those kinds of things. But it can also be integrated with third-party engineering services organizations. We have one that is doing it with us now, and we're open to conversations with others who would like to be in that conversation. So that system is very much resident on patents that Vayu has and work that it is doing with Palantir and Qualcomm. So remember that we're solving in the biggest way the significant issues that come from wake impact, and what we're seeing there is very significant upside creation of new capacity to support wind farm ability to take advantage of ancillary tariffs and deliver greater power, greater revenue, and we're in like a 5-year period now where this is a better solution than some of the solutions that people are thinking about for storage purely because of cost and opportunity. And so with the increased capacity that comes from either a repowering or running a site plan according to a wake steering modality, you end up with a better ability to provide the grid with wind when there is availability, and then cut out when that availability is not there. We can dive into that a little bit if anybody wants to. There's an NREL paper that everybody should know about. I'll pop up that document here for a second. I don't know if you guys are going to see this, but this is an evaluation of the potential for wake steering on land-based power plants. I mean, we're all familiar with the concept that we're beginning in about 2000. We started, going to lower density models out of concern that bigger turbines were bringing greater wake to the wind farm, and it is that low density which we're dealing with by bringing a wake steering scenario that can increase the ability to put higher density to work. That's a key element of this. Is this white paper? Anybody wants to get the documentation on this from me? Happy to send it to you. So getting back to, I lost something here. Let's see. I'll get it back. All right, so now we're back in the spot. So, all right, so now we're going to talk about business a little bit here, about what happens because of what you can do here. So, powering with Vayu, we dropped the white paper in the Vayu room, and there's a good amount of information there about what we're doing. But there's a pre-powering activity with any wind farm that we're dealing with in terms of developing a strategy for maximizing its capacity and increasing the power generation. The way we do that is by running extensive baseline analysis that confirms the capacity and the ability of the wind farm to execute test loads, system loads, and enables us then to literally do deployments. While we're doing this, we're empowering the wind farm with financial alternatives that provide for a better approach to things like full volume hedge kinds of issues that have come into play. Texas had some huge problems on that last winter, right while we were presenting at Leadvent, and so the idea then is that we secure and deliver investor support to make sure that the deployments we're talking about can be done without cost or risk to the wind farm. This includes wind revenue puts against the new capacity, and that enables a better transaction for the wind farm with respect to acquiring lower cost commercial funding as opposed to the risky hedge documents. This then enables a major financing to be put in place to actually secure the capacity, and the capacity gains that we're seeing are generally going to be in the range of 2 to 10%. Again, we can talk about that more extensively. So in the powering approach really is all about this. I'm not going to dive into that here, but the idea is that with all of the systems we're bringing and the partners that are coming along with us, that we're able to deliver on the premise of better financing, capital to support implementation, and then full systems integration with OEM technologies, so that we're not in a place where we have conflicting judgments around how things should be undertaken. As I mentioned, we've got this major repowering initiative underway right now. We've run full assessments. We call them performance optimization assessments on pretty much every U.S. wind farm. And in those assessments, there are a couple of critical things that come out. Number one is that most wind farms, as the NREL study says, can achieve additional capacity through planned higher density deployments, which involve either putting new turbines in or putting more powerful turbines in existing locations. But at 30% and as high as we're seeing them as high as 68% in some cases, and even more. Along with that comes the greater power production when wake steering is deployed in certain locations, and we can talk about strategies for wake steering implementation according to those baseline analyses that I mentioned. I also want to show you what we're doing with site planning, and so I'm going to show you a GIF file here in a second.
Jim, we got about 3 minutes left, just for you.
Okay, well, why don't we just run it then?
All right.
So in this GIF, what you're going to see is a wind farm layout. Numerous layouts go into what's on the left, and as you can see, as you change the layout, you pick the power locations that you can go. We're going to run it again, so you can see that this one is run without a wake steering implementation, and so we can run the same thing with a wake steering implementation, which will show an even greater power impact. Happy to talk with anybody about that. Okay, here we go again. All right, so yeah, and then we have this is a repower assessment that's in progress with a couple of major wind farms based on our work with the NREL white paper, and we're deploying bigger systems to support a increase in capacity, and then gains. This wind farm will go up by about 54% when all of the work is completed, and we're actually expecting to see additional gains that'll be fairly dramatic. Our proposals always involve us paying for the costs that are associated with the deployment and facilitating the advanced financing behind that. And in each case, we're going to do that extensive baseline analysis before anything's done, and then structure the commercial agreement. And that's what we've got. So